Okay, so the last one we were doing categorical variables. Now we're going to do some of these continuous variables, still using female as our predictor. So this means that we need to do a t-test. So we would say proc t-test data equals HSB2. And this is going to be our class variable is female, and then our actual variables that we're comparing these by are all of our math, read, write, social studies, all of that. Since we already have this here, I just like to copy paste to save a little bit of time in typing. And then we go ahead and press run. And let me clean this up just real quick. There we go. And you highlight this and go ahead and press run. And the thing I like about this is that it gives you the means and standard deviations of each of the two different categories. So we have the females and the males, and they each have, their mean and standard deviation provided. So this very first one, we have the math score. So let's go ahead and highlight that. So for females, we had a 52.4 plus or minus 9.2. For males, we had 52.9 plus or minus 9.7. Remember to check the test for equality of variances looking at the folded F. So for those of you who are unfamiliar with folded F test, what this is doing, it is the null hypothesis for this is that the variances in the two different categories are equal. That's the null. So if we reject the null, meaning that the folded F is less than 0.05, this tells us that the variances are unequal. And so the reason we have to check for this is we have to use different p-values depending on whether the variances are equal or whether they're unequal. For this one, the p-value is greater than 0.05, a lot greater than 0.05 actually. And so we can go ahead and assume that the variances for both of these groups are somewhat equal. We can also kind of tell just by looking at the standard deviation here. And so for the p-value that's reported, we use the pooled method, which has equal variances, so 0.68. So even though for this one example, the p-values look like they're not too different, there are sometimes some circumstances where the p-values will be starkly different. So do keep that in mind. I also like that it shows us the distribution for both of these variables. Next one we have the reading score. For females it was 51.7 plus or minus 10.1, and then for males it's 52.8 plus or minus 10.5. We also check the folded F test again. We can use the equal one because it's greater than 0.05, and so the p-value for this one is 0.46. Next test, we have the writing score. So for female, it was 54.99. Let's go ahead and round that up to 55. And for the male, or actually standard deviation first, 8.1. For male, we have 50.1 plus or minus 10.3. The reason you saw me rounding up, just go ahead and moving it to 55 is if I round up this 9, it's already going to make it 55, just in case that becomes a question for someone. So this is a pretty good example of there being unequal variances. And so this is also demonstrated by the p-value for that folded F test. It's less than 0.05, meaning we would need to use the Satterwhite method of unequal variances for this one. This one is a little bit different from each other, although they're both still significant, but we want to make sure we're reporting the correct p-value of 0.0003. You can also kind of see this difference. It seems like it was the female group that was causing some of that skewness before. For science, we have 50.7 plus or minus 9.0 in the female group. And then, actually, we don't need the O. That's kind of implied. And then 53.2 plus or minus 10.7 for this group. It's close to less than 0.05, but it's not there yet, so we can go ahead and use the pooled method for equal variances, so 0.07 for that one. And our very last test, we have 52.9 plus or minus 10.2, and then 51.8 plus or minus 11.3, and then seems like we meet the equal variances, and so our p-value is 0.46. And so that's the rest of our variables. So I mentioned before, make sure you give this table a decent title. Decent title basically means that I can read the title of this table and tell what kind of information I can get from it without actually even looking at the table itself. It's kind of like whenever you see those research papers and they have the title of the table right in the text, and then you click it when you feel like it has the data that you want. So this, I'm just going to be very simple. Comparison of, let's see, participant characteristics and test scores by gender, because that's kind of what we did. And we already have our note here. And my last part, I love to change the border design just to clean it up a little bit. So I got my top, my bottom, and then my bottom for the very first row as well. This lets you know when the table has started, what is the header, and then when the table has ended.